Alright, ladies and gentlemen, so you can see on your screen we have 14 minutes and 59 seconds to complete a presentation. This video is brought to you by Hacho's Toy Shop. Please don't forget to search up my Instagram at Hacho or my personal one at Cho_Abraham. So we have 15 minutes to do this presentation. We have 29 or 30 slides, I do not remember. We will do this properly, ladies and gentlemen. Here we go. So, ladies and gentlemen, good morning. My name is Abraham Cho Jin Ming, and I'm here today to present to you the enzymatic hydrolysis of chicken feather waste for the production of multipurpose high-protein organic fertilizer. My supervisor today is Associate Professor Dr. Mickey Vincent. So, ladies and gentlemen, chicken feather waste is a very common protein-rich waste product of the poultry industry with no clear use case. Every time you eat the chicken, where do the feathers go, ladies and gentlemen? Every single chicken has feathers. So you ever wonder where they go? They go straight into, most of the time, landfills. So, chicken feather waste consists of 8% chicken mass. It is high in creatine and recalcitrant, therefore the disposal is very challenging. You can see in this photo, this is the landfill area at one corner of a chicken farm that I had the privilege of visiting. So it's just disposed of like that, just thrown in a landfill, and lack of standardization and optimization in the process of producing creatine hydrolysis has been found with varying results from multiple researchers. So this is what we aim to tackle here, ladies and gentlemen. After you eat the chicken, the feathers need to go somewhere. So the feathers need to go somewhere, therefore we're here to take these feathers, which would normally end up in landfill, and make them into something that's actually functional. So hold on. Okay, our objectives here are, first of all, to produce high protein organic fertilizer from chicken feather waste using the enzymatic hydrolysis method. To evaluate the optimization potential of the production process of chicken feather waste based high protein organic fertilizer, and to evaluate the plant growth promoting properties of high protein organic fertilizer produced from chicken feather waste using in vivo tests. So, ladies and gentlemen, here is our research hypothesis. The HPOF produced does not possess plant growth promoting properties, and the alternative hypothesis is that it does possess plant growth promoting properties equivalent to or higher than our control. So, first of all, chicken feather waste is a byproduct of the poultry industry. It is generated during the slaughtering process. This is where we get our main source of protein, because we are doing high protein organic fertilizer. It consists of 91% creatine, and creatine is a form of protein. Creatine hydrolysis, more on this later, finds applications in healthcare products, cosmetics, and fertilizers. However, it consists mainly of beta-carotene, which is bound through multiple disulfide bonds that bond amino acids together to form recalcitrant fibers. So, it's biodegradable, biocompatible, and it is non-toxic. All of this is very beneficial for our purposes, because our biofertilizer needs to meet all these parameters so that when it rains, it will not leach into groundwater and contaminate the water supply. It will not cause adverse effects for the next generations of plants that will be planted on that same soil. So our core ingredients are completely non-toxic, completely friendly to both humans and animals. It also has desirable nitrogen, phosphorus, and potassium content, also known as NPK content. So here in this diagram, you see the basic structure of a human hair, but this is analogous to chicken feathers as well. It is formed out of multiple different layers of fibers, which is why you see the protofibril, macrofibril going into melanin, going into intermicrofibrillar matrix. All of this is very tough. Many fibers means extreme toughness and extra challenge to process, which is why high protein organic fertilizer is rarely produced from enzymes alone. So For organic fertilizer, it's a product that supplies nutrients to plants, which is produced from naturally occurring substances. It provides nitrogen, potassium, and phosphorus, and a higher amount of protein from commercial fertilizers. Chicken feather waste fertilizers can produce slower nitrogen release compared to commercial biofertilizers, which enhances plant growth. So the difference between our organic fertilizer and other potential biofertilizers or fertilizers, ladies and gentlemen, first of all, here is an example of organic fertilizer. Chicken manure, smelly, slightly toxic, but in theory, extremely high nutrients and extremely high absorbability by the plants. We want to match this or be better than commercially available versions of fertilizer, ladies and gentlemen, because we will be using enzymes. First of all, we'll use pepsin. This is commonly found in human gastric juice, and its purpose is to break down the peptide bonds that are in the keratin protein. It breaks them down into polypeptides, and it creates shorter chains of peptides, which will in turn be digested by keratinase. So keratinase is an enzyme that targets the keratin found in biomass. And chicken feather waste, if you remember, is 91% keratin, ladies and gentlemen. So there's plenty of keratinase to work on the keratin. This will be our selling point for our biofertilizer, ladies and gentlemen, because this keratinase breaks down the disulfide bond of the peptide, which forms amino acids that can be absorbed by plants. Why are we claiming these enzymes as our ultimate selling point? This is because most chicken feather waste applications are in biofertilizers in tandem with beneficial microorganisms and not in solely enzymatic applications. Ladies and gentlemen, enzymatic applications have a gap to be exploited because they do not introduce microorganisms into the environment. Now, yes, microorganisms may be beneficial to the plants, they may be beneficial to the soil, but what if you have a scenario where you do not want to infest your soil with those microorganisms? So this product aims to be free of microorganisms and just purely chemical action. So the second research gap is that the increasing cost of conventional fertilizers opens up a gap in the market. Ladies and gentlemen, cultivating microorganisms can be challenging, and the R&D that goes into the biofertilizers represents a significant investment into the development of the biofertilizer itself. removing that and replacing it with solely enzymatic applications is what we aim to do in this research project. So, first of all, here is our methodology flowchart, ladies and gentlemen. So we have several different stages. So, the first stage is production of high protein organic fertilizer from chicken feather waste. So, chicken feather waste will be acquired from a small scale farm from Serian. So, this is me. This photo right here. This is me at the chicken farm. This is the front of the farm. So, obviously, we were not allowed to take photos because of trade secrets. But what you see here is 1 and 2 of the chickens that are slaughtered on demand every 1 to 2 weeks, and the chicken feather waste will be taken after the slaughtering process. The feathers will be taken from a rotary defeathering machine. So, next stage is pre-treatment of chicken feather waste. We'll be using chicken feather waste that will be cleaned with cold water and dried overnight at 50 degrees Celsius to remove impurities and contaminants. So, you can see on the right, this is the before we grind it using the grinder. It's in long, extremely tough fibers. So after we grind it, it forms extremely fine fibers, still fibers, but extremely fine, that is more easily processed because we'll be using this manual grinder. It's powered by muscle energy, ladies and gentlemen. So, I forgot to hit transition. Boom. So, alkaline hydrolysis will be carried out using sodium hydroxide. 25 gram of chicken feather waste coarse powder will be mixed with 1 liter of 0.5% sodium hydroxide and heated to 100 degrees Celsius with stirring for 5 minutes. So this will help break down this will help with general breakdown, because sodium hydroxide is a bleaching agent. It is also something which targets general bonds. It doesn't care what bonds you have. It is caustic. It is a bleaching agent. It will break down the chicken feathers into much smaller components, into much finer powder, which will then be allowed to cool down overnight under constant stirring. The pH will then be adjusted to 7 plus minus 0.2 using sulfuric acid. So here are all our parameters, ladies and gentlemen. Here is our ultimate selling point. We will have 6 different parameters that we will test for our enzymes. So we will be adding enzymes at 0 hours and 48 hours in all these different combinations that you see on the screen. So this will help us to evaluate which combination of enzyme, or maybe no enzyme, is most functional out of all of these combinations. We will be adding them after the mixture has been cooled to room temperature to prevent them from being denatured. So our negative control is no enzyme, and the creatinase and pepsin will be tested separately before being combined in different combinations. So at these intervals, the samples will be taken for analysis. Approximately 50 ml will be taken every interval for testing, and the results will be used to adjust the final product. Scanning electron microscope will be carried out at these magnifications. This will show a breakdown in chicken feather waste fibers. Oh my gosh, sorry. And the results will be used to adjust the final product. Because here is the ideal result. Before and after. Before processing, you can see one long, nice fiber. After processing, the fiber is in pieces. This will help break down the fibers, releasing all the proteins inside for the plants to absorb. We are making plant food, ladies and gentlemen. So total soluble protein and NPK analysis will be carried out using the nanodrop machine. At the same intervals, NPK analysis will be done by external labs, because we will have many samples to test from, and I do not believe it is practical to actually manually do them by hand for 6 different parameters multiplied by triplicates. Because, ladies and gentlemen, in order to help with our verification of our data, all results will be triplicated. So per batch, that's 6 times 3, 18 samples per interval that will be tested. So that's 18 times 1, 2, 3, 4, 5, 6, 7, 8 intervals. I'll let you do the math yourself. So the results will be used to adjust the final product, and will be compared with protein content from commercially available fertilizer. So, excuse me. So, weight reduction analysis will be carried out at these intervals to ensure that the fiber is broken down. The pH analysis will be carried out so that we do not accidentally make it too alkali or too acidic and accidentally kill the plants with the plant food with our high protein organic fertilizer. Here, ladies and gentlemen, is the in vivo analysis of high protein organic fertilizer. So we will carry out analysis using live plants. Samples from 120-hour interval will be used as proof of concept. The data will be used to select the optimum interval to use for future tests. The controls will be commercially available A and B fertilizer and distilled water. The Kratky non-circulating method will be used, as you can see here in our prototype design. Bok choy, green salad, and chili will be used because of their extremely fast growth, as well as their visible fruits for in the case of chili. So, statistical analysis will be carried out using one-way ANOVA test and TUK-HSD, and we expect to produce HPLF from chicken feather waste, optimize the production process, and analyze the plant growth promoting properties. So no additional harm will be carried out to animals, and the methodology will be carried out according to standard biosafety compliance standards. Here is my work schedule, ladies and gentlemen. We plan to be done by 2027. Here are the references used, and thank you so much. Are there any questions? So, ladies and gentlemen, we had 5 seconds remaining because we started at 14:59. So, ladies and gentlemen, I do think that is not a very successful run. My introduction needs to be more bombastic. I am Mr. Bombastic. So, that is not what how do you say? This introduction has to be better, honestly. I'm not happy with the introduction. And then I noticed that in one of the slides there was an error in the spacing. I can't remember which slide it is, but I have to go back and check. And all of these slides, right? This does not tally with this. I have to make the mind map tally. And this photo I think is pretty ugly. I'll have to find a better photo for this. I have to also brush up on my like high protein organic fertilizer. Like I have to brush up on this literature review. Because honestly, I need to find the photo for the chicken feather for this one also. Because this is actually a hair. It should be analogous. It should be the same as the what do you call it? It should be the same as feather. It's just that the feather has more branches. But I really need to change this photo. And this photo keeps on appearing because I really don't have any other photo. I'm not that good at slide design. I admit it. I'm not that good in slide design. This is Canva design, but oh my goodness, I think it's ugly, man. I really could do better, but like, yeah, I don't know, man. I invested so much time into doing the literature review and reading up that I didn't actually do the slide properly. Oh my gosh. Okay. So that's all the things that I can come up with you so far. If you want this slide, let me know. If you have my number, if you have my WhatsApp, then you know lah. If you don't have, please don't forget to comment underneath. Please don't forget to like and subscribe. And please buy some toy cars from me, because I'm making this at like 9 at night, and I hope that no one has woken up, because like my voice is actually really loud. I'm sorry guys. Alright, don't forget to like and subscribe. Bye.